Welcome back, Space Invaders. So this is a unit on space that we're going to be looking at over the next couple of weeks. So you've done a couple of activities already. What you've done is created a model of the universe which shows the size and vastness of the universe. The purpose of that was to look at the different relative locations of all our planets and the vastness of our universe. You look at, we have a closely clumped group of planets, and then we have vast planets off in the distance. Just give you the sense of scope and size of our universe. And the difficulty of even trying to get out the planet. So we've been able to get to the moon. Our next closest planet we're going to go to is Mars, and that looks like a couple of years away. So again, just the vastness of exploring our space. The second activity you did was you took on the persona of a planet or a celestial body and then created a vlog, which then allowed you to understand further what it is in terms of making up our planet. And there's good old Gary Gold. So today you've been working on 4 experiments. You can work in partners, but you had individual working. Again, there'll be a series of questions to go along with the experiments and for you to think about. The key again with the science is being able to explain why you think things are happening. Okay? So really think deeply about what you're writing. Really think it up fully. Francesco, when you think you've answered the question, write more. Gallo, that goes for you too. So there'll be a number of items at the back. We'll have to coordinate one of the experiments and work together. But you'll have plenty of time to get it done. So the first experiment involves the sheet of paper and the graph paper. Okay? So you'll find the paper at the back. You'll tape or glue, I would tape, the graph paper to the construction paper. Okay, working with a partner, you can take your flashlight. You're going to need 4 different colored pens. I have 2 here. And basically what you're going to do is firstly, take the paper, hold it straight up and down, and you're going to turn your flashlight on and hit it with a beam of light. Roughly about, a foot away, okay, or 2 feet. And it's important that you remain the same distance apart each time. Once you've hit the beam on the piece of paper, you're going to take your marker and you're going to circle where the beams, hey pooch. You're going to circle where the beam is hit on your paper. Okay, that's step 1. Then what you'll do is you'll take a different piece of paper, again holding the beam. You're going to tilt your paper slightly on the same piece of graph paper, different color. You're going to trace that beam, right? And then you're going to tilt further, trace that beam, and you're going to do it 4 times. So you'll have it straight, tilt, so straight, circle the beam, tilt it, circle the beam, tilt it, circle the beam, and finally tilt it again and circle the beam. Right? And what you're looking at is comparing the area that the beam covers. Okay. Also, you think about the intensity. So when the beam is straight on, what is the intensity of the light hitting the paper as opposed to when it's tilted? Okay. And see, is it covering more area or less area? Maybe seem pretty intuitive to you, but it's important to understand how the beam is being affected by the tilt and the intensity of the light on the tilt. Okay. And then you have to draw this connection to our Earth and our further experiments. Okay. So that's experiment number 1. The second experiment, what I'll do is I'll probably set up a schedule for you. It's going to take a bit of recording and setup to do. So you'll find at the back thermometers, 2 of them posted on black construction paper and bound to cardboard. What we'll do is we'll set up a schedule for you to do this experiment. We'll find a sunny place, usually the rollaway behind Molly, Kayla, and Sophia is a great place to do this experiment. We need the sun, so probably in the afternoon. What you're going to do is look at thermometers, make sure that the temperatures are the same when we start this, and you're going to set them up in 2 methods. You're going to use some textbooks. So you're going to take one of the thermometers, and you're going to set it up on an angle. So you want to make sure it's tilted. So if you look this way, it's on an angle. So we want it nice and tilted. Okay, and it's in the beam of the sunlight. And then what you're going to do is place the other one beside it, make sure it's also in the sunlight, flat. Okay, we're going to record the starting temperatures of each, and then for the next 45 minutes, every 5 minutes, you're going to be coming and looking at the temperature and writing down what the temperature is for each thermometer. At the end, you're going to see which thermometer is of greater value, so which area is hotter, and then be able to explain why you think each area is warmer. So if I'm laying it flat, should this thermometer be warmer, or should this thermometer be warmer? And at the end, you're going to tell me why you think, the thermometer is warmer. Obviously, it might have something to do with the angle and lying flat, but then you need to be able to explain using the idea of the intensity of the rays. Okay, kind of connecting back to this experiment. Okay, so that's the second experiment. This one we'll do is we'll set up a schedule, and you may do this one out of order. So in fact, you may do this experiment first and then do the other ones later, depending on the due date. Okay. The last 2 sets of experiments involve a ball and working with your partner. Hey, pooch. Ball. Okay, you'll notice that there'll be an elastic on the ball. Leave the elastic. The elastic represents the equator, or the center of the Earth. Obviously, this is the northern part of the world. This is where we live. This is the southern part of the world. Okay, so the first experiment is going to be quite simple. But again, the importance of the observations, understanding what's going on in our world. Okay? You're going to take some textbooks. You're going to have it about a foot away, and you're going to put your flashlight on, and you're just going to hit it with a beam. Okay? What I want you to look at, because now we have a curvature to our Earth, how is the beam, intensity of the beam looking? So this is the center of the beam. Is the beam spreading out this way, spreading out this way? And what would be the effects if I lived up here and I lived up here, or if I lived along the equator? So if this is the sun and the beam is hitting it, where is the beam most intense? And how is that affecting people that live here? How is that affecting people that live up here or down here? And how is it affecting the food we grow and how we organize ourselves and all that kind of stuff? Okay. The second thing you need to do is you need two people. One person is going to be the sun, the other person is going to be the earth. And again, what I want you to be doing this is thinking about the three areas. Okay, the northern part, the equator, and the southern part. So someone's going to be the sun, they're going to be in standing, and what you're going to do is take the ball, again holding it as such, and flashing the beam to hit the earth. Okay, the first thing you're going to do is you're going to tilt. Okay, back and forth. So step one, you'll just stand and you'll tilt the ball back and forth and examine the beam. Okay, so what do you notice about what's happening with the beam when I tilt this way, and what happens to the beam when I tilt this way? Okay. So the intensity of the beam, is it changing? So as I tilt it towards the northern part, towards the light, is that changing? As I tilt it to the southern part, is that changing? And what happens in the middle? Does that stay the same? Does that stay different? And how does that affect in terms of the seasonality of the Earth? The second thing you're going to do is you're going to rotate. Again, picking a spot. So if this is your starting point, and as you rotate the Earth, what do you notice? That happens on this side to this side again with the beam. The last thing you're going to do is, takes a little bit of coordination, you're going to tilt, rotate, and turn. Okay? And the beam is going to follow you. So you're going to be taking the ball, you're going to tilt it towards the beam and rotate at the same time, meanwhile going around in a large circle. And the beam will follow. So you'll take the beam, and if I was to do this, I would go all the way around, following the beam, tilting and turning. Again, what I want you to be looking at is the intensity of the beam as it is hitting the ball. Okay, and again, as always, there'll be a series of questions to answer for each experiment. What we're looking at is how is the light being affected by the curvature of the Earth, the tilt of the Earth, the intensity of the Earth, and how does this affect how we live? So when we look at this stuff, it's like, okay, we know the beam is here, it's more intense here or more intense up here. How does it affect we live, and how does it affect the decisions we make? So again, for the 4 experiments that you'll be doing this session, the first one works with the paper, where you start off flat and you hit it with the beam, you trace it with a colored marker, and then what you're going to do is tilt the paper, and each time you tilt the paper, trace it with a different color, and then compare on the same piece of paper the different beams that hit the light. The second one we'll set up for you. I'll give you a chart. You'll set it up with your partner. One of the thermometers using some textbooks will be tilted. The other one will be flat. And then you'll record the temperature at different intervals. And again, explain to you why you think there's a difference in temperatures. And again, explain. And if you're going to say it's just because of the tilt, you need to explain how that affects it. So it's the intensity of the beam I want you to think about. The last experiment involves the ball with the equator, hitting it just in the middle there, and then observing the beam. How is the beam spreading out? Where is it most intense? The last one, of course, is you have someone simulating the sun. The first one is just merely tilting, the rotate, and then the tilt, rotate, and track. And again, always looking at the beam. What I want you to look at is how does the curvature affect? So when we have something that's flat, right? So if I compare this beam to this beam, so we're kind of doing the same thing. Here's a flat thing, I tilt it. How does the beam look? This is a curved thing, and I'm tilting it. How does the beam look? Does that make a difference in terms of the intensity of the rays and that kind of thing? All right. As always, there'll be a series of questions at the end. Make sure you answer them, explain them fully, and if you need any help, I'm always there. And happy exploring.